Welcome back. Okay, so in the first episode, or first lesson of the week, we go through the yab commands on a very bit by bit basis, making basically one or two commands at a time and unraveling what it is they do. But for the second one, I thought that would be a bit boring. I think it would be much more interesting if we take a real actual program and see how it works. So let's have a look at those example programs. We're going to start with a very simple one. It's called clock.yab. Now the extensions, by the way, are quite arbitrary. You can use yab, you can use bass, you can just leave it off. And let's move that to the desktop so we can work with it and maybe either today or in a future episode change something in it and see what happens. Alright, let's get info, make sure that it's writable and executable. Close this down and let's get ourselves a terminal. So first, let's see what it does. There, throws up a little clock with the date and the time and keeps it running. A bit of flickering, yeah, but yeah, it's okay. You basically got the same thing over here, so it's not something that you desperately need to compile and spread to the world. Let's have a look at that code. Let's make that a bit more readable. Okay, so how does this start? Window open, 100, 100 to 200, 150. This is what you use to open a window. So it is 100 pixels across, 100 pixels down. And you want to be a little bit careful with this because you don't know what size your user's screen is. So generally I'd say open your windows in this upper left corner and then they can move it wherever they want to. See, but if you running quite a large resolution and you put it down here in the bottom right and your user is running a lesser resolution, then the window will be created but it'll be off screen. So over here and it goes to 200, so it's 100 pixels wide to 150, so it's 50 pixels high. Okay, so that's not very big, as we have seen. Then we call this main view. Now that's the name of the window. And that is what you'll be using in the documentation. It's called the ID. And every gizmo and gadget and widget you create will have its own ID. Yeah, even if it's something like text that's immutable and cannot be changed, it'll still have to have its own ID. Okay, and then clock is what will appear here in the tab. Next, we have a few commands to, just set up the what kind of window this is. So this one is not zoomable. You see, there's no little zoom widget here in the tab, right? And it is resizable. Let's see, we can resize it. Oops. Let's see. It is not. You see, because the minimum size and the maximum size of this window are the same. So you still have the little thing here to resize it, but you can't actually change that because they're both the same. There's another setting that you could use there, is not resizable, and then this should disappear completely. Right. Then layout, left, top, right. Okay, you can go and look at that at the documentation for that, but that is the one you'll probably use. Now that means that whenever you change something, whenever you change the size of it, it all gets calculated from the top right, top left corner of the window. Right, and then on top of the window we put a view. Now this is good programming in YAB. The window itself is a view, technically speaking. You can put all this text right on top of the window itself. But it's better to create a view. Now, you can see the view goes from 0, 0 to 100 to 50. So now you're working this not in terms of the screen. Window opens is in terms of the screen. Now you're working it in terms of the window, which is 100 by 50. So we put this view from 0, 0, which is right there in that corner, to 150. Okay, so now somebody's going to say, but wait a minute, 0 to 100 is actually 101 pixels, and 0 to 50 is actually 51 pixels. Well, YAB is just very forgiving about that. You can put a view that stretches further than the window, right? And more technically, I suppose you could say, we should have put this 0 to 99 and 0 to 49, but YAB doesn't really care about that. So it's very forgiving. Same way if you'd said 1 to 101, 1 to 51, then that 1 pixel down here would not have been used. Okay, so now we come to the main loop, and every program you write will have a main loop. This is a very simple program, so something, it's a very simple loop. So here, quit requested or quit. So this little program is constantly sending messages, right, which we intercept. It's sending messages to Haiku and receiving messages from Haiku, and we intercept it here. This is a reserved keyword which we then feed into this variable, right? And we've got it here to print everything out, which will only happen if you're running it from a terminal. Here you can see it activated, deactivated, and at the end there's quit requested, which happened when we clicked on the quit widget there, and therefore that ends this while when loop, and therefore it jumps out of the main loop and it closes the window with all the views on it and exits. While that is happening though, while you have not asked to quit the program, something else, draw time and date. Now, there we go. Time and date. Here you see two subroutines. We'll talk about that in the other half of this course. So, YAB does not distinguish between subroutines and functions. There's just one kind of subprogram, and it's called a subroutine. You started with sub and you ended with end sub. Very easy, very simple. So we have this one which gets called in the main loop, right? So the first thing is it calls the other one, and the other one is just a little thing that finds the actual time and date. See? And you can look up all of those here. The date command and the time command, they're built in, and so it splits those strings and finds the little piece that it wants, which you do here with midstring. So we've now got that. We've got the variables Zeits, dollar, and datums, dollar. Okay, so what do we do with it? Well, first draw flush clock view. Remember, clock view we set up way back here. Clock view. It's the name of the one view on this window. Then there's draw text, and draw it 10 pixels across, 20 pixels down. And we start with the date with this variable here, and we draw it on clock view. Then we draw text again, this time the variable containing the time, and you can see that goes 35 pixels down from the top. And then you wait for a quarter of a second. Okay, so this subroutine calls that one, gets the data, and since this is a tiny little program, we don't have to localize the variables, but you could, I suppose. Alright, and that brings us back here. Then it sleeps 1/100th of a second, just to give everything a little bit time to settle down. So you've Now, total waiting time there is 0.26 of a second if you add those up. And then it goes back. So this thing would be an infinite loop, except that we've made it respond to either quit requested, which is this one, or quit, which is if you try to kill it from here. Right? If I try to kill it from here, then it will send that quit remark. Now, in a more complicated program, you would have a menu and you'd have a quit on the menu, and then that would also be added here. Okay, so if you're a complete beginner and we haven't really touched all of this, we haven't done a while wind loop yet, we haven't done subroutines, then just go to the documentation and read all these commands. And you'll see how quickly, really, they'll start to make sense. It looks like hieroglyphics now, I know. But once you've read the documentation on these commands, right? So if we look at the main loop, it starts with in loop equals true. You define the numeric factor in loop to be true. True is actually another way of saying 1. And then here, if you find this in the message that the program and Haiku keep sending each other, then you declare that factor in loop to be false, which is another way of saying 0. Then when you get here to the end of the main loop, it says, let's see, okay, while in loop, so this has to be something other than 0, but now we've declared it to be 0. Therefore, we end this loop. And what is next? And that is the wait out of the program. Now, it's a very good programming practice that in your entire program there has to be exactly one exit point, right? And which this program has. This is the exit point. And that is a good idea, because if you have 6 different exit points in your program, then sooner or later you're going to forget about one of them and you're going to change the way the program exits. Maybe you wanted to do something else, you wanted to say bye-bye, and then one of your 6 exit points is not going to do it. So it already has one entry point, which is here, and every program should have one exit point. Now, the program would actually exit without the exit command. But this, it cleans up the memory, it, makes sure there are no loose variables floating around to confuse other programs. It just is a cleaner way of doing it, and it reminds you that this is where your program ends. Okay, so that is an analysis of this very simple, how many lines is this? 37 line program called clock. Oh, we could probably squeeze it down to 20, but it's very readable the way it is, so we'll just leave it there. Thanks for watching. I hope this way of doing things is helpful. Yeah, but let me know in a comment. Do you want me to go on like this and just analyze small programs? Or would you like a whole lesson just on window open? The way we're doing it on the first lesson of the week. Let me know.